All right, let's get right into it. It feels like every single week there's a new, bigger, more powerful AI model hitting the headlines. But today, we're going to talk about something a little different, something from Baidu called Ernie 4.5. And honestly, it might be pointing to a huge shift in the entire field. You know, for the last few years, the story in AI has been pretty simple. It's all about size. The race was on to build the absolute biggest models you could imagine. We're talking hundreds of billions, even whispers of trillions of parameters. And because of that, a handful of well-known giants kind of dominate the whole conversation, right? It's this incredibly high-stakes competition, pushing the very limits of what's possible with computing power and, well, a whole lot of money. But hang on a second. What if that's not the whole story? What if this race to be the biggest, the most massive, isn't the only race that actually matters?
Yeah, what if the real game changer is all about efficiency? You know, how to get that same jaw-dropping performance without needing a supercomputer the size of a city. That's the big question that Baidu's Ernie 4.5 is really trying to answer.
So let's properly introduce this new contender, Ernie 4.5. And it's not just one model, it's actually a whole family of them, all built on this philosophy that's about being smarter, not just bigger. And they're tackling one of the trickiest problems in all of AI. And that problem is this. How do you build a single model that's a true expert in understanding both text and images, without the two sides kind of getting in each other's way? This is where the design behind Ernie gets really, really clever. Okay, so pillar number one of Ernie's approach is its architecture. We're basically talking about how they designed a smarter brain for this AI. And it's all built on a fascinating concept called mixture of experts. So instead of one giant monolithic brain trying to do absolutely everything, an MOE model has a whole team of smaller, specialized networks. When a task comes in, the model only wakes up the specific experts it needs. The hospital analogy is perfect. When you're sick, you don't see every single doctor in the building, right? No, you get sent to the one specialist who knows exactly how to fix your problem. It's just a much, much more efficient way of doing things. Now, Ernie 4.5 takes this idea and kicks it up a notch. When you feed it both text and image data at the same time, this smart router acts like a super efficient hospital receptionist. It instantly sends the text stuff to the language experts and the image stuff to the vision experts. But, and this is the secret sauce, it also uses a set of shared experts that understand both. This whole system creates this deep, unified understanding where the two different specialties work together instead of interfering with each other. It is a brilliant way to build a true multimodal expert. Okay, but having a smart brain is one thing. It's pretty useless if you don't have a smart factory to actually build it. And that brings us to the second pillar, the incredibly efficient training infrastructure behind Ernie 4.5. I mean, let's be real. Training these giant models is notoriously difficult. It costs a fortune, it uses an unbelievable amount of energy, and things can just fail, wiping out days of progress. Baidu tackled these problems head-on. They use these clever solutions like FP8 precision, which is just a fancy way of saying they do the math faster by using a more compact number format, and some really advanced load balancing to make sure no computing power goes to waste. They even built fault tolerance right into the system, so if something breaks, it can recover quickly without losing all that progress. And the result of all this engineering? A 47% model flops utilization, or MFU. So what on earth does that mean? Well, think of it like the fuel efficiency of your car's engine. It's a measure of how much of the computer's raw horsepower is actually being used to train the model versus how much is just being wasted as heat or idle time. Getting to 47% is a massive achievement in this space. It means their factory is running incredibly lean, with almost no wasted energy. So we have a smarter brain, we have a more efficient factory, but what does all that get you in the real world? Well, that brings us to the third and maybe the most important pillar of all, making this ridiculously powerful AI accessible to, well, everyone. And this is where it all comes together. Because of all that efficiency, Ernie 4.5 can be dramatically compressed using a technique called quantization. The best way to think about it is like turning a gigantic, uncompressed audio file into a compact MP3. The quality is almost identical, but the file size is just a tiny fraction of the original. This means the biggest Ernie model can run on just 4 GPUs, or, with a bit more compression, even a single one. That's a game changer. It makes this level of AI available to way more people and businesses. And here's the best part. Baidu isn't just hoarding this tech for themselves. They've actually open-sourced ErnieKit and FastDeploy, which are the very toolkits developers need to train and deploy these models. The key here is that they're not just releasing a model, they're releasing an entire ecosystem to help other people build cool stuff with it. And this quote from their technical report, it really just says it all, doesn't it? It shows this clear desire to push the whole field forward, to focus on collaboration and speeding up progress for everybody, not just for themselves. Which leaves us with this final thought. For such a long time, the AI race has been defined almost entirely by size, who has the biggest, most powerful model. But models like Ernie 4.5 are suggesting a totally new direction. It's a future where power isn't just about raw scale, but about smart design and incredible efficiency. A future where the winner might not be the biggest, but the smartest.